Hello everyone, welcome back to the channel Infinity by Yashaswini. In the previous lesson, we uncovered the hidden magic of perfect squares. We solved the famous 100 locker mystery, discovered why some numbers are called perfect squares, learned amazing exam shortcuts, and explored how square numbers appear in real life. But today we are going to learn something even more exciting. Today we are going to reverse everything we learned. Yes, instead of finding the area of the side, we are going to find the side from the area. Sounds interesting. So far, we have discovered two amazing patterns of square numbers, that is, adding an odd numbers. Then another one is square number doesn't ends in 2, 3, 7, 8. But now I'm going to show you one of my favorite mathematical patterns. It almost look like magic. Look carefully the screen. See, 11 square is equal to 121, means when you multiply 11 with 11, that is 11 times 11 is 121. What happens when we square 11? We get 121. Now let's add one more digit. That is 111 into 111. That is 111 times 111. We get 1, 2, 3, 2, 1. Yes, that's look interesting. Let's continue. That is, if you are squaring 4 ones, what you are getting? 1, 2, 3, 4, 3, 2, 1. And finally, if you are adding 5 ones, that you are squaring 5 ones, we get 1, 2, 3, 4, 5, 4, 3, 2, 1. Can you see the hidden beauty? The digits don't appear randomly. They first count up, that is 1, 2, 3, 4, 5. Then they count down 4, 3, 2, 1. It's like climbing a staircase and then coming back down. So see here two ones are there. So the highest number is 2. 1, 2, then go back to 1. Now here 3 ones are there. So 1, 2, 3, again 2, 1. Coming back to 1. Here 4 ones are there. So the highest number is 4. Here 5 ones are there. So the highest number is 5. Can you guess for this? How many ones we are having? 7. So the answer is 1, 2, 3, 4, 5, 6, 7, 6, 5, 4, 3, 2, 1. It's amazing. The digits seamlessly scale up to the number of ones, then perfectly come back down. Why does this happen? Mathematics isn't just about calculation, it is also about patterns. When identical digits are squared, their multiplication creates perfect symmetry. I have challenge for you. Can you find it without using a calculator? Think carefully. Yes, the answer is 1, 2, 3, 4, 5, 6, 7, 8, 7, 6, 5, 4, 3, 2, 1. Because how many ones are there? 8 ones are there. So the highest number is 8. Amazing. Once you understand the pattern, you don't even need to calculate. The fun fact is, many competitive exams include pattern based questions. Instead of solving lengthy calculation, they test whether you can recognize hidden mathematical patterns or not. So far, we have learned how to create square numbers. Now comes an important question. What if someone gives us the final answer and asks us to find the original number? Let's learn the opposite operation. Let's begin with a story. Imagine your father wants to build a beautiful square garden in front of your house. An engineer visits your home. After measuring the land, he says the total area of your garden is 64 square meters. Now your father asks, what should be the length of each side? Can you answer? Take 5 seconds to think. Most of the students immediately remember area of square is equal to side times side. That's correct. But today the situation is different. The area is already given, that is 64 square meters. What we don't know is the side. Can we still use multiplication? No. Now we have to do the reverse of multiplication, and the reverse process is called square root. Let's understand it with a simple question. What is 8 cross 8? Exactly, 64. Now let me ask the reverse question. Which number when multiplied by itself gives 64? That's right. It is 8. So we say that square root of 64 is 8. So we say square root of 64 is 8. And we write it as square root of 64 is equal to 8. This is the symbol we use to represent the square root. Congratulations! You have just found your first square root. So what is square root means? Let us take another example. Imagine you are buying a square carpet for your living room. The shopkeepers tell you that the carpet covers 100 square feet. Now you ask, what is the length of each side? You don't have to measure every side. Simply think which number is multiplied by itself gives 100. Exactly. It is 10. If you multiply 10 with 10, you will get 100. So, each side is equal to 10 feet. That's the power of square root. Here, we can say that square root of 100 is 10 because on multiplying 10 with itself, we get 100. So 10 is the square root of 100. And here each side is equal to feet. Now we'll take another example. A farmer is having a square shaped field. Its area is 225 square meters. He wants to build a fence around it. Before buying the fencing material, he first need to know the length of one side. How can he find it? Think 15 times 15 is 225. Each side is equal to 15 meter. Without square roots, this simple task becomes difficult. See here 15 we are multiplying with 15 or itself to get 225. So square root of 225 is 15. Can you think of any other situation where we know the area but need to find the side? Maybe a playground, a floor, a chessboard. Pause the video and think. You will be surprised how often square roots appear in our daily life. See, square root is an art of coming back to the square number. If square is building a grid, finding the square root is measuring one side of the grid. Look at the diagram. When we move forward, 8 becomes 64. That is 8 times 8 is 64. 8 square is 64 here. This is called squaring. Now we reverse the process. We start with 64. We ask which number creates this? The answer is square root of 64 is 8. This reverse journey is called square root. Think about traveling. Going from Bangalore to Mysore is one journey. Similarly, squaring goes forward. Square root comes back, like from Mysore to coming back to Bangalore. Suppose a square park is having an area of 441 square meters. Instead of measuring every side, we simply calculate square root of 441. That gives 21 meters. So each side of the park is 21 meters. Architects use this idea every day while designing parks, rooms, playgrounds, and buildings. Now we know that why square roots are useful. But what exactly is a square root? Why do we use this strange symbol? Let's understand the meaning behind it. Let's go back to something you already know. Suppose we know the square numbers from 1 to 10. Okay. Suppose a square has a side of 4 centimeter. What is its area? We know that area is equal to side times side, which is equal to 4 cross 4 is 16 square centimeters. Right? Suppose area is equal to 16 centimeters square or square centimeter. Can you find the side? Of course, the answer is 4 centimeter. Finding the original number from its square is called finding the square root. Then what is square root? A square root of a number is the number which when multiplied by itself gives the original number. In simple words, a square root tells us what number was multiplied by itself. For example, to get a square number, we are multiplying the number by itself. So, which number is multiplied by itself to get a square number is called as a square root of that number. And this is the symbol used for square root. We'll take some example. What is the square root of 1? Which number multiplied by itself gives 1? Exactly, 1 times 1 is equal to 1. How we get 1? By multiplying 1 by itself, we get 1. So the square root of 1 is 1. We'll take another example. What is the square root of 4? By multiplying which number by itself we get 4? Exactly. It is 2 times 2 is 4. Therefore, square root of 4 is 2. What is the square root of 9? Exactly. On multiplying 3 with 3, we get 9. 3 times 3 is 9. So, the square root of 9 is 3. What is the square root of 25? Exactly. 5 times 5 is 25. So, square root of 25 is 5. Easy, right? Let's play a quick game. I will tell you the area. You will tell me the side. Ready? Area is equal to 36. Then what is the side? Think. Exactly. Side is equal to 6. Now one more. Area is equal to 81. What is side then? Exactly. It is 9. Because 9 times 9 is 81. One more. Area is equal to 144. Can you guess the side? Exactly, it is 12 because 12 times 12 is 144. Excellent. You're already finding the square roots mentally. We'll see visually. Imagine you're arranging tiles. There are 49 tiles. Can you arrange them into a perfect square? Yes, exactly 7 rows and 7 columns. Since 7 cross 7 is equal to 49, the square root of 49 is 7. Now imagine you are arranging 64 tiles. Arrange them exactly. You are arranging as 8 rows and 8 columns. So, square root of 64 is 8. This visual method helps you to understand square roots instead of memorizing them. Now we'll discuss some real life applications. Square roots are used in constructions. Builders knows the total floor area. They calculate the side length using square roots. Even we use in garden planning. Landscape designers use square roots while designing square gardens. Even we use in technologies, computer graphics and game developers use square roots to calculate distance between the objects. GPS navigation, they also used square roots. Navigation system calculate the shortest distance using formulas that include square roots. Even in sports, we use square roots. Sports coaches use square measurements to design practice courts and training areas. See, square roots are everywhere we are using in our daily life. Let us discuss some common mistakes you make. The first mistake is you write square root of 25 is equal to 25, which is wrong. The correct answer is square root of 25 is 5 because 5 times 5 is 25. The mistake number 2 is you usually confuse 5 square and square root of 25. Remember, 5 square means 5 times 5, which is equal to 25. Whereas square root of 25 asks what number gives 25 when multiplied by itself. The answer is 5 because on multiplying 5 by itself by 5 we get 25. So square root of 25 is 5. And the third mistake is you usually forget that square root is the reverse of squaring. Always ask yourself what number was multiplied by itself. That is the square root of the given number. Without using a calculator, answer these. Pause the video and answer. Here is the solution. 6, 7, 8, 10 and 11. Perfect. Do you know this amazing fact? This symbol, the square root symbol, is called the radical sign. Mathematicians have used it for hundreds of years. Whenever you see the symbol, your brain should immediately think, I'm finding the original number. Now you know what exactly a square root is. But here is the next challenge. How do we find the square root of bigger numbers like 256, 576 or 2025? Should we keep guessing? Of course not. Mainly there are three methods we use to calculate the square root of any number. That is, the first one is repeated subtraction method, the second one is prime factorization method, and the last one is estimation method. In the repeated subtraction method, we subtract the number from consecutive odd numbers until we get 0. Then count the steps. It is usually ideal for very small numbers. We cannot do it for large numbers. And the second method is prime factorization method. Prime factorization method, in this method, we break down the given numbers into a prime numbers, then we pair up and take one from each pair. This is ideal for perfect squares and large numbers. Then the last one is estimation method. Pin the number between the two nearest noun perfect square, then we calculate or we estimate the number. It is ideal for quick approximation and non-perfect squares. We'll discuss one by one. Let us discuss repeated subtraction method. In the repeated subtraction method, for example, we'll take 16. So subtract 16 from the consecutive odd numbers. The first odd number is 1. 16 minus 1 is 15. Again 15 you subtract from the second odd number, that is 3. 15 minus 3 is 12. Then again 12 you subtract from the third odd number, which is 5. 12 minus 5 is 7. And again 7 you subtract from 7, which is the fourth odd number. 7 minus 7 is 0. So stop here because we got 0. Till you get 0 you have to repeat the subtraction. In how many steps we subtracted? 4 steps. Therefore square root of 16 is equal to 4. Easy, right? We'll take one more example. For example, 49. 49 minus 1 is 48. Again 48 subtract by 3, second odd number, which is equal to 45. 45 again subtract from the third odd number, which is 5. we get 40. Now 40 subtract from by 7, we get 33. 33 minus 9 is 24. Again 24 minus 11 is 13. Now 13 minus 13 is 0. Stop here. In how many steps we subtracted? Exactly 7 steps. Therefore, square root of 49 is 7. But it is a lengthy process but easy one. It is usually ideal for the smaller number, but it is not ideal for the larger number because it is the lengthiest process. Before learning another method, I want to ask you something. Many students ask, Ma'am, where will I ever use square root in my life? Have you ever asked yourself the same question? If yes, today class will completely change your thinking because square roots are not just exam concepts, they are used everywhere. Today we learned what is square root, patterns in square root, why square roots are useful in real life, how to find square roots using the repeated subtraction method. In the next class, we'll learn how to find the square root of any number using prime factorization method and also estimation method. So if you like this class, comment your answers, subscribe to Infinity by Yashaswini. Until then, keep learning, keep exploring, and remember, maths isn't difficult, the right explanation makes it beautiful. See you in the next class. Bye.